YouTube. Okay, here we go.
Yay, okay.
So as I was
I'm
saying,
not going to do
I absolutely love word problems when I know how to do them, right? And I actually sometimes like them when I don't know how to do them, if I feel like a challenge, right? But, you know, and as long as I can learn it, and then I can get good at it. But, so we're going to do a lot of word problems this year. One number is 4 times as large as another. Their sum is 35. Find the numbers. Now, you could easily use guess and check, right? You could use the guess and check method. You could say, okay, one number is 4 times as large as another, so we could do 1 and 4, right? And 1 plus 4 is not 35, shoot. So we could do 2, and then 4 times 2 is 8. 2 plus 8 is 10, thank you. And then that's not 35. And you could keep going until you found the answer, right? It would take a while, and it's not, that is not,
So what's the equation?
that is not the algebraic way to do it, right? So what we're in the process of doing is figuring out ways to set these things up algebraically. And one of the things I recommend, there are different ways to do this kind of problem. And we are going to do it with just one variable, okay? Eventually there will be ways to, I'll teach you ways to do it with 2 variables. But if you have 2 variables, like an x and a y, in order to solve it, I'm just going to say this. This is sort of like you don't have to write this down. Just listen to it for a second, because this is not part of my solution. But if I had one of them be an x and one of them be a y, notice if I had x plus y is equal to, I'll just say 10 for now, right? This has nothing to do with this problem right now. If I have x plus y equals 10, and that's all I have, there is no way I have any idea what x and y is. I cannot solve for x and y. Does that make sense?
Yes.
If x were 1, what would y be?
9.
Yeah, but what if x were 2?
8.
But what if x were 3?
7.
But what if x were negative 2?
It'd be
12, right. So we don't know. It could be any of those. I have no idea what x is or y is, right? I could graph it. I could graph a line of all my possibilities, right? Does that make sense?
Yeah.
When x is 1, y is, whatever.
But it
I
would
could
go
do
on
that.
forever.
And it would go on forever. It would be an infinitely long line, right? But it would never tell me what x equals and y equals. It would just tell me what x would equal when y was this, right? Or what y would equal when x was something, right? That's all it would tell me. But if I have 2 unknowns, an x and a y, right? 2 unknowns. The only way I can solve this equation is if I have another equation. I have to have 2 equations. 2 unknowns, 2 equations. All right, and if you don't believe me, I'll give you an example. Here's another equation. Y is equal to 4. That's an equation, right?
Yeah.
What's x?
6.
Suddenly it's so easy, right? Right? 2 equations. You have to have 2 equations in order to solve a 2-variable problem. You have to. What if you had 3 variables? You'd need 3 equations. What if you had 4 variables?
4.
4 equations, right? You'd have to have, if you were 3, if it was x, it would be z plus x plus y, you'd have to have somebody tell me that z is 1, right? And then, right, yeah, exactly. So you just need to do that. You have to have those. Now, sometimes these second equations might not be like y equals 4. It could be x plus 4. Or it could be, z could be 2x minus 3, right? And then it's kind of weird. And so, but we'll get there. We're going to get there. But that's not what we're going to do today. We could set this up using this method, but we're not going to do it that way. Today we're only going to use 1 variable, okay? And so we're going to use a little bit of logic to set this up. So it says one number is 4 times as large as another. Which of the numbers? There's 2 numbers. We've got this number, 1 number, and we have another number. Which one is the foundational number, the base that everything's dependent on?
1.
Lila. What? It says one number is 4 times as large as another. So which would I rather know first? The one number or the another number?
Another number.
Do you guys agree with that?
Yeah.
Wouldn't that be easier?
Yeah.
I mean, I could do it the other way, you know, and you could too, but wouldn't it be easier to just know, if I knew that this was 2, I would know that that one would be 8, right? Because it would be 4 times 2. If I know this one first, so to me, this is the foundation, this is my base number. And so I underline it and I put an X right above that word, another. And it's almost always the second number when you do these problems. And these pretty much always, it'll be the second number. That's your X, right? Now, what would I say for this number though? How could I write the value of this number now that I know this number? 4x? Would it be x plus 4 or 4x?
It would be
4x.
4x plus y. It equals.
Well, wait, we don't have y's,
You're
right? We're just keeping x's now, right? We can do the y's another time, but then I'd have to teach you a whole thing about systems of equations. I don't want to do that today, right? So,
Wouldn't it have, if it was like 4x, and then another was also x, wouldn't both x's have to be the same value then?
yeah, well, x will be the same value, but the numbers will be different, but x will be the same. So let's try it. You'll see what I mean. So we've got our first number is x, right? One of our numbers, let's say, is x. Our another number is x. This says one number is 4 times. So the second number would be 4x, right? 4 times x, 4x. Everybody with me on that? Does that make sense? If I had said one number is 4 more than x, what would it be? X plus 4, right? If I said one number is 10 less than x, would it be 10 minus x or x minus 10?
X minus 10.
Would be x minus 10. 10 less than, you always have to put the 10 less than to the right, and then back in the space you left is the thing you're less than, right? I can't say, Mike, did you know that Michael is 4 less than? He's 4 what?
4 less than what?
Right, you gotta have the what first. You can't have 10 less
Like a
than.
wicked what?
You gotta have the what before you know the 10 less than, right? So you always write the what first, and then you do the minus 10 last, right? Does that make sense? So whenever you see, in this case it's not there, but if you had greater than, if you had more than or less than, you always put that plus 10 or minus 10 to the right, and then come back to the space you left. And you put the what, right? Less than what, right? You gotta have the what. That's the most important part. So, but this doesn't have the less than or more, it's just 4 times. And look, that word times tells you immediately what to do. Multiply, right? Times is multiply. So we've got those two numbers. Everybody's with me on that, right?
Yes.
And then it says, their sum is 35.
So x plus 4x.
So x plus 4x equals
35.
35. So now what do I do?
You have to divide 4x by 4.
You had to bring together the x's.
Oh, yeah.
London.
together.
Yeah, so London. So, yeah, first, before you divide, you see, now if Ben was right to some degree, except that if he did that, this is what he'd have to do. He'd have to divide this by 4. Don't write this down. He'd have to divide this by 4, and he'd have to divide this by 4. First of all, I wouldn't want to divide 35 by 4. Secondly, I wouldn't want to divide x by 4, because then I have 1/4 x. Now I'm dealing with all these weird fractions, right? I would rather, it would work. We could do it, and it would work, what you said.
It just take long.
It would take a lot longer, right? So I would rather combine my like terms first. And you guys, do you all know what I mean when I say like terms? Is there anybody that doesn't? Like, I'm going to just say, like a like term, if I had 2x plus 5x, these are like terms because they both have x's, right?
Yeah.
That says I have 2 x's, and that says I have 5 x's. I'm adding them together, then I can add them and it would be 7 x's, right? If I had 2x plus 5y, those are not like terms. That's like I have 2 apples plus 5 pears equals how many pears? Right? 5 pears,
pears.
right? You can't combine it. You can say you have 7 fruit, right? But you can't say you have, suddenly 7 pears, just by, you know what I'm saying. They're not like terms. Now, are these like terms? 6x plus 2. Is that 8x? No, there's totally different. This says I have 6 x's, and this says I have 2, not 2 x's, just 2, the number 2, right? So 6 x's plus 2, I can't combine them. They're not like terms. So I'm looking for things that have the same. Are these like terms? 6 plus 2.
Yes.
Yeah, because neither of them have x's. They're just numbers, right? Are these like terms? Yes. So I have 0 x's plus 4 x's, that's 4x, equals 35. Am I right? No. But see, there's nothing here, so that's a 0x.
There's a one.
What?
One.
What?
Always a one.
There's a 1 here? Oh. So whenever there's nothing, so 0 equals 1?
No.
No, okay. So there's nothing here, but there is a hidden 1. Everybody knows that for
Yeah.
sure? So then suddenly I'm wrong. Jeez. 5x is equal to 35. All right, now it sounds going to be pretty easy. Divide by 5, right? Divide by 5, x is equal to 7. If x is 7, am I done?
No.
It says find the numbers. So, and this is written in words, right? So I have to write my answer in words. So it says, so I'm going to say the numbers are 7 and, now let's see, how do we find the n?
We multiply 7 by 4.
We know that, yeah, so this says, oh, right here. If this was my original thing, right? My first number was x, which is now 7. My second number is 4 times 7, which is 28. So then I would say 7 and 28. Does that make sense?
Yeah.
See, if you always write your numbers in the top left of your box where you're working, you always can go back at the end. Once you've solved for x, you can go plug that in, right? And then you can tell me what the two numbers are. Does that make sense? All right, so that's the first one, fist to 5. Does it make sense? You all get it? Awesome, great. All right, good. So good beginning. So I'm erasing, is that okay? I'm erasing. Should I write down the answer? Now it's going to be abbreviated. The numbers are 7 and 28. And I'll put it in a box, and then I'm going to let Michael take a picture.
Does it?
Do you have your camera?
Does,
Oh, you know it?
Also, if you want to
Oh, well, that's true. That's a good point. Eh,
so
Yeah.
Gary,
where did you find me? You guys are so smart. Yes.
does it matter if you put the abbreviated or not?
Like this?
Yeah.
I'm okay with this.
Okay.
I'm okay with this. Some math teachers wouldn't be, but I am. It's fine. But I just want to see it as a sentence because that's the key. Oh, some math teachers will just annihilate you, right? And if you don't write, if they ask it in words, you got to answer it in words. If they ask it in a mathematical equation, just solve it, right? But okay, so that's that one. So now we are going to quickly write the next one together. While I'm writing it, you write it, so that we're basically sort of done at the same time. Does that work for you guys? All right. So here we go. Number
2.
Sure, I guess I'll do number 6. I'm going to do number 6, okay? You guys are so lucky that I'm doing the homework for you. Okay, one number. So write this down. I'll read it as I'm writing it, so you can write it. One number is 6 more than another. 6 more than another.
Wait, 6 what?
is 6 more than another.
6 more what?
God, you guys are awful. No. All right, we'll get there. We'll get there. 3 times, oh, this is going to be weird. 3 times the smaller is, 3 times the smaller is equal to, where am I? Twice
Whoa.
the larger
Makes no sense.
decreased by 10.
I put decreased it in. I just put decreased it in.
If Gideon is 17 feet tall.
Yes!
No, that's, no, just find the numbers. I guess that's all. We'll
But-
keep it simple.
I'm finally tall. Nope.
In
I
mine,
mean,
in
I was saying
Minecraft,
like
I'm 6 feet tall.
All right,
No, actually, that's true.
Yeah, Minecraft,
Every
I'm 6
block
feet
is a
tall.
meter.
Yeah.
Okay.
Yeah.
It's 2 blocks tall, I'm 6 feet tall.
If you already did do it, you it in our homework.
uh,
Same height.
Yeah.
sure, do it without even, I mean, use it as a thing, but go ahead and do it. In the homework, you just do it anyways, right? You'll know how to do it. You'll do it really fast, and you can check your work, right?
Yeah.
With your notes. All right, so same idea. We're only going to have one kind of variable, right? So that means we've got to turn that first sentence into 2 things, right? So first of all, I immediately go, one number is 6 more than another, which is my foundational number. Another, right? You guys all see that? So that's my x. I always make my foundational number x. So I have an x, and then I have one number is 6 more than x.
One number is 6 more than what?
Yeah, so 6 more than,
What?
right? That means I move it plus 6 off to the right. So I'm gonna go plus 6 right here. More than, what's the word? What?
X.
6 more than x, right? So we're gonna put the x first. That's my foundational number. That's my base, my root, right? And then I'm gonna add 6 to it. Does that make sense?
Yeah.
Okay, so then it says 3 times the smaller. Oh gosh, does it matter? Can I just make either one of these smaller?
No.
No.
The x, just x is smaller.
But what if x is negative? I mean, does that matter?
Yeah.
It's still smaller.
It's still smaller because it's not, it doesn't
So
have
this
that
is
extra
still smaller,
6.
isn't it? Yeah, because this one, I'm adding 6 to it. No matter what x is, this is always gonna be larger. So I'm gonna actually put this here smaller. I'm gonna just give myself that little hint that x is smaller. Okay, you with me? Does everybody make sense? Does that make sense to everybody? 3 times the smaller. How would I write that? 3x. Now look what I'm doing. I'm actually doing one word at a time when I write these. It's really important to understand this. It says 3 times the smaller. We just wrote it, 3x. And then it says is equal to, what would I write for that? Equals. And then it says twice the larger. How do I write
It
that?
would be 2x plus 12.
2x plus 6, like that?
12. Because you have to, it's distributive.
All right, so I'm gonna write it like this, so that you guys can all see what's happening, okay? You're right, it could be you could write it as 2x plus 12, but it's twice the larger. The larger is x plus 6, so twice is 2 times, right?
Yeah.
2 parentheses. So whenever you have a binomial, you have 2 terms, an x and a 6, with a plus sign or a minus sign in between, you always put parentheses, right? So 2 times that. And then it says decreased by 10. Minus 10. Wow. That's awesome. Does that make sense?
Yeah.
You see how easy that was? As long as you follow it one word at a time, and you can do that. So suddenly, let's solve it. So we have 3x is equal to 2x, because we're going to do our distributive, plus 12 minus 10.
You can simplify that even more
Yeah.
because there's -10 but there's already a +12, so it'd be 2x
Ah.
plus 2.
So this could actually be just 12 minus 10 is 2, right? So I could go 3x is equal to 2x plus 2, beautiful.
But you're gonna have to put
Oh shoot, we have these doggone x's on both sides. It's impossible to solve this.
Oh,
nothing's impossible.
nothing's
It
impossible.
is
Gary.
until we move those x's, right?
You subtract from the right and add to the left.
You're gonna do minus.
Well, what would you do? What would you do, Gideon? What
That's
would
what
you
I'm asking. Don't you subtract the x's from the right and then add them to the left?
Well, it depends on.
Well,
Which
remember,
side
what's the golden rule of algebra say? The
Do
golden,
one to one side is who
did you guys hear what he asked? Gideon asked an interesting question. He said, wouldn't you subtract these from the right and add it to the left?
No.
Well, what does the golden rule of algebra say?
Do one to one side is who, do one to the other.
Right, so if you
Add-
subtract from the right, you have to subtract from the left,
Okay, so
Oh.
right? You can't subtract and add, you have to subtract. So, yes, so Mira, help me. You,
So then you'd subtract 2x from both sides.
subtract 2x. All right,
x
so then I have
equals
x is equal to 2, right?
But the
One number,
numbers,
we need two.
numbers.
So am I done?
No,
No.
there's numbers.
So I could come back here and say, well, if x is 2, that's 1, and then what's x plus 6? 2 plus 6 is 8. So those would be my answers. So the numbers are 2 and 8. And I'll put it in a box. I love boxes because I can find your answers.
Dude, then you would love
It's
Minecraft.
amazing how well people can creatively find places to put their answers.
Gary, if you
In
like
the
boxes,
most
you would love Minecraft.
unlogical place ever. It's unbelievable. It's incredible. So, fist of 5, does this make sense? It's fun, right? It's fun. You gotta admit, that's fun. And if you can get in that habit of, I actually, when I write these out, I actually have my finger on the sentence. And I actually, okay, 3 times the smaller, and I keep my finger there, and I write 3x, right? And then is equal to, I keep my finger there and I write equals. And I go twice the larger, 2 parentheses, the larger is that, x plus 6, and then decrease by 10, minus 10. I keep my finger, I go all the way through, left to right, through that verbal equation, verbal sentence, to find my mathematical sentence. And they're really fun. Okay, so that's it. It won't be a very hard assignment. Well, it might be. There might be a couple that might be a little challenging on there. So we'll see.
Are you
I
in your
am
video?
Subscribe. Dying.
so